Good morning, everyone. You are welcome in AI-with-Rav, and let's make AI simple. And in this journey, machine learning series, ninth day, we are going to know about XGBoost, learning from your own mistakes. And in this model and algorithm, we are going to follow these sequence. What is it? How XBoost is different from random forecast. Why fixing mistake beats voting. Okay, and simple idea of boosting one step by other step, and why it wins almost every competition. Okay, so no delay, let's start that one liner. And what is it? XGBoost builds tree one after another. That's one line. Each new tree fixes the mistakes of one before it. It's like a student who only re-studies the questions they got wrong. Okay, that's why it wins the competitions. Now let's start with the story. The way we actually understand the problem is there are two students, and the first student A, the way of study is different. He or she studies like they did 10 rounds of revision, same book 10 times. Okay, this is the nature of A, how A does the study. Now there is another student that called B, and B means boost, and his full name is XGBoost. How does he or she studies? It learns some first time, okay, whatever the and just appeared in the exam, and in after appearing the exam, whatever the mistakes, let's see, she has done, next time she will correct her mistakes. She will not go through all the questions, she will just correct her mistakes and appeared in the second exam. Again, after appearing the second exam, so whatever the mistakes she has done in exam 2, she will learn those mistakes only and correct it, and then appeared in the exam 3. Now you can guess whose strategy is the best one, who will get the best marks and who will win the competition. It's student B, and that the model is XGBoost. Okay, now see the key difference in the diagram. Now the whole picture will be completely clear. In random forest that we studied, what is happening? Everyone at one time, every tree in the forest at one time were giving their consensus, their vote, and we were taking and saying that okay, this is the consensus of each tree in the forest, whether it's a yes no or a number. If it is yes no, majority, and if it is a number, average. That's it. Now the whole approach is completely different in boosts. How boost works? XGBoost, first tree in the forest will make a decision, but you can see it can make a mistake. Now this decision will be taken to the tree 2, but tree 2 will do, it will fix the mistakes done by tree 1, not the whole thing. It will just fix the mistake. They are all so friendly that they will conjugate each other, they will boost each other. Whatever the mistake tree 1 has done, it will pass that, hey listen, now I have done this mistake, can you fix it? Now tree 2 will take, say, and it will correct those mistakes. Now again tree 2 can't fix all mistakes. Now tree 2 will pass his mistakes or her mistake to tree 3, that hey listen, these are the mistakes still left, can you fix this? And this sequence will keep going. You can imagine at the end you will have the best possible answer, and that we call label. Now we can understand the build one after another. You see, each new tree looks what the earlier tree has got wrong and try to fix that only. Learn, then fix the mistake, then learn again. Style has name boosting. Now you understand why this name is boosting. I will tell you why XG is there. It also has meaning. Okay, now go to this word. A crowd voting all at once. Okay, XGBoost, a team where each member fixes the last one's error and both use same tree. Tree is same but the approach is different. But XGBoost fix the mistakes. Approach usually squeeze the more accuracy out of it. You can see right now here, each new tree studies the leftover mistakes. So there is tree 1, tree 2 and tree 3. Only 3 trees are there. Now tree 1 gets a lots of right, okay, but makes mistakes also. This is a big error. Say it made, I'm just calculating in number, say 100 error it made in number, and now it will pass, and tree 2 will take say 50 error. It corrected 50 error. 50 errors are being corrected by tree 2. Now how many errors are left? 50. Now tree 3 will not take 100 error. It will work on remaining 50 errors, and if it can solve all 50, that's done. You had perfect answer now. So this is tree 1 makes big mistake, tree 2 studies those mistakes, tree 3 fix and is still wrong, and then keep doing, and that is the superpower accuracy. That's what it is happening. Now we can see tree 1 takes the test, okay, and gets a lots of right but also makes mistakes. Tree 2 does not redo everything. It will not start from scratch. It will just fix the mistakes that tree 1 has done, and will tree 3 will do what tree 2 has done, and will keep going until and unless a final sharp answer is not being achieved. Okay, so this is what the whole picture is, and you can see the graph right now. That is a quantitative analysis. In y-axis we have mistakes left over, and in x-axis trees number roughly. So one tree is there and it has say about 6.5 something left over, then 2, 3, and you can see the pattern. The number of tree increases, the leftover mistake also increases, and it outperforms all those previous algorithm that we discussed. Okay, so that's what it is. It is really the great one. Okay, and XGBoost so accurate, it does not stop at good enough. It will keep doing, but it also has some disadvantage, and that is this is the problem of overfitting. So if you have 1000 trees and one is taking another one, so if you can say it keep hunting down the leftover mistake and tree at a time until very little is left over. But be careful, if it hunts too hard, it starts memorizing. That's called overfitting. We will learn about this overfitting, and there is a way to even overcome this problem, and that we call breaks or a setting. The setting we will do that, look, don't hunt for n number of times. I will give you a logic what you should follow, and if you ask me the formula, you don't need derivative, you don't need calculus, no differential equation, nothing, just simple addition, tree 1 tree 2 and each one small fix on top of the last. Now I discuss you what is the break that we will apply, and the break, the settings that we will do is two things, is learning rate and number of trees. If we can define that, listen, this is the learning rate, one tree will not learn the everything or all mistake that tree, a previous tree has done. You will only fix 10%, okay, in one go. You don't need to do 100%. So we fix the rate, how much you can learn, and the tree number, okay, roughly say, not start like 1000 tree in one go, it will start memorizing, and this is called the fine tuning. If you can like tune this model, that's like best, and that's the whole idea. Keep adding a small correction. The XG in XGBoost means extreme gradient, a fast, clever way of choosing each fix. You don't need the heavy math to use it well. You need to know it fixes mistakes step by step with breaks. You got point? You got the point? You just define that, listen, this is the rate and this number of tree. So 10% each tree will correct the 10% mistakes of previous one, and in one go 5 tree or say 100 tree will participate. Done. Then again it will break, again it will do. This is the fine tuning how we will do. So now let's see how we write the code. So here is the model. I have imported that from XBoost, and here XBoost classifier, and these two parameters are what? These are the settings of breaks. We applied, listen, 200 trees, how many trees? Okay, round of fixing, how many round of fixing will be there? 200. Okay, and learning rate, the size of each fixing, like break 10%, 0.1, and depth at one go 4 tree will participate. We define the setting. Now train the model. Model will learn a pattern genuinely, and after that we provide our input or feature that to predict income, age and credit, and now it will tell that person should be given like loan or not. And if we can also feature importance, we can find which is the most important clue that we can present to our boss, that sir, listen, this was the important thing that was happening in the model, and that's on based of this model predicted the decision. That's create accountability. Now when to use it, okay, and when not to use it. See, based on table data, I discuss same on other algo, but need a little fine tuning. Okay, it really, like, it is a great algo and you can do that and just tune it perfectly and you will get the best result. Look, this is not for image, text and speech, and for that we have deep learning. I will cover that after covering machine learning, and this is the seed we are giving of what? Deep learning. Okay, and can overfit if paused too hard, too many trees and too big learning rate memorizes and it breaks. So just remember these points only. And now the recap what we learned so far is the XBoost builds on one after another. Simple. One tree fixes the mistakes of tree that has done before. Okay, now this is like a student who studies only the wrong answer. You studied one time, went for test, you appeared for test and you saw not the whole paper, what are the mistakes that you have done. Next time you will only learn those mistakes the wrong things that you have done, you will correct it and appear in the exam again and keep doing until you will become a topper. Now the formula, just adding the tree and breaks. Okay, mindfully we have to apply the breaks, and breaks are learning rate and number of trees. That's called fine tuning. And Kaggle, like it's the king on Kaggle. Any data, loan, fraud and sales, it's science. And now in the 10th video, this is very interesting, and this is like a psychological thing also. K nearest neighbor, like who you are defined by the nearest people are there with you. 5 nearest people, you are the average of that. That's what this machine learning is, this KNN. Okay, so let's start with day 10. Thank you so much for being there till now.